Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Hello friends, as you know there are numerous organic compounds and because of which the naming of them would be very much difficult for us. Hello friends, as you know we are talking about alkanes and alkanes can be of numerous numbers that could contain the number of carbon atoms, and because of which we have also got to know that they are been classified into various types, that is primary, secondary, tertiary and quaternary. So we have also did the isomers of that, and in that we have got to know that the two carbon atoms or the two molecules which have the same molecular formula but of different structural formula will behave differently when it comes to the chemical property or the physical property. So therefore it is very much essential for us to give the name to the carbon atom followed by a particular structure. So that's the reason IUPAC naming is very much important for us to differentiate the two structures that are isomers or that have different property. So not only for naming or to differentiate isomers with the help of a name, but it is very important for us to assign a name for a particular structure of a particular molecular formula. So that is the reason IUPAC is very necessary. So now let us learn what are the rules that we are going to follow while giving the nomenclature to a particular alkane. So let us talk about that. So friends, now we are going to talk about the rules of IUPAC nomenclature for alkanes. So there are various rules that we have to follow, and because of which we could give the name of a particular compound or a particular molecule when it comes to an alkane very easily. So let us start with the first rule. It is very easy to understand, but let us first of all understand what are the rules that are being that we have to obey while giving the IUPAC nomenclature to a particular alkane. So starting with the first one, it says that the longest continuous chain of the carbon atoms in the structure of a molecule is selected. That is the thing. We have to select the longest continuous chain of the carbon atoms that are being present in a molecule. Yes, this chain is regarded as the parent chain and it is given the name of the parent hydrocarbon. So if whatever we choose the chain or the continuous chain, that would be considered to be the parent chain, or and because of that, and how many number of carbon atoms that are being present in that chain, that would be named as the total number of or we could say when it comes to the IUPAC name, that would be the parent hydrocarbon, and because of which the nomenclature will be decided. For example, this is what I am explaining. Suppose if we have a 6 carbon atom, and which is nothing but an alkane in a hydrocarbon that we have, suppose, so that could be written as in this manner, or that could be written in this manner. सर ये कैंसिल, इसके बदले में दूसरा पेज लेता हूँ. Suppose if we have a 6 carbon hydrocarbon like this one that I am drawing, that I am making a 6 carbon atom to be or a hydrocarbon to be this, or we could also write it as this one. So now the both are having the same molecular formula, but yes, the both are being different with each other. How? So if we choose the longest chain, or if we give the IUPAC name, and if we have followed the first rule, and the first rule says that we have to follow and we have to choose the longest continuous chain. So talking about the first molecule that we have, so we could choose the longest chain easily, and that would be this one. It is fine. And in this case, basically the total number of hydrocarbons that we see in the straight chain that we have chosen, and in this case it has been found that 1 2 3 4 5 6 hydrocarbons are been there. So therefore that would be the parent name of the whole alkane. So in this case, because there is 6 carbon atom in the alkane, and because we know that the numbering starts, if we have 1 carbon atom, it is been called as methane, 2 ethane, propane, butane, pentane, hexane, heptane, octane, nonane, and decane when it comes to from 1 to 10 10 carbon atoms that are being present in a hydrocarbon. So because this is having 6 carbon atom, so therefore, and even the all are in straight chain, so therefore the name of this would be hexane. And this hexane, because this is the parent name that we have, and more even we could say that this is in a straight chain, so we could also call it as n-hexane, but more preferable it is called as hexane itself. And this is basically nothing but it tells the information about the how many number of carbon atoms are being in a straight chain, or are being in a continuous chain. So this is what the hexane is. But talking about the second one that we have to follow the first rule, and the first rule is we have to choose the longest continuous chain of carbon atoms. So if I have chosen the carbon atom to be from here, as I am drawing from another pen, suppose if I choose the carbon atom from left to right or right to left, I can choose in any way also. So suppose if I choose this one, so this is the longest chain that I have got, or I have predicted that whether this would be the longest chain. So according to this, what I can observe is 1 2 3 4 4 carbon atoms are being in this straight chain. So therefore this would be the parent name of the hydrocarbon. But moreover, we could see that if I choose the number, if I choose the longest continuous chain in this manner, where I could see even I could choose in this manner also, where I could say 1 2 3 and 4. Again 4 carbon atoms are in a straight chain. So while as I've differentiated by 2 inks, as you could see for the red ink that is been enclosed in that, so we could see 4 carbon atoms, and in this case also, that is in the green ink, that within the green ink I could see that there are 4 carbon atoms that are been enclosed in that line. So again this is 4 hydrocarbon or 4 carbon atoms that I observed. So it is not necessary. So the main thing is, it is not necessary that the continuous chain should be straight. It could bend in a corner also. So that is what I want to explain, and this implies to follow the rule to be that the longest chain may not always be straight. So the longest chain may not always be straight, or we can turn into a corner also. But yes, one more rule that I want to explain, that if we have started from left to right, we cannot take the U-turn in that. For example, if I'm choosing in this way, that is 1 2 3 4, I can choose this carbon to be 5. So 1 2 3 4, and it will go on straight or continuous manner, and it won't come back in the same direction while counting, because every number is being every carbon atom is being numbered, just like the roll number that we have for the students that we have. So this carbon would be said to be number 1, this would be 2 3 4, and once it is being numbered as 3, it cannot be changed, or we can't double number it. So that is the rule that we have to think about. So in this case, what happens is we are numbering. So in this case, the total number of carbon in straight chain in this case is found to be 4, and 4 is nothing but known as basically butane. So the parent name of this would be butane. So therefore, but in this case it is hexane. So therefore, the molecules are being different, and this is the substituent that we are observed. So let us talk about that also in the rules that we are going to observe. Yes, if two chains of equal length are present, choose the one with maximum number of substituent as the parent chain. Suppose if we have a molecule in which we could see that there are multiple chains that are, or there are multiple groups that are been attached to the straight chain. So in that case, what we have to choose is we have to choose the one with a maximum number of substituent as the parent chain. So what is this that is they are talking about? So let me give an example for that. Suppose I'm not drawing the hydrocarbon, I'm just naming it with a skeleton. So now I'll just draw this skeleton, or we could say just the structure with related to carbon atoms. So for that, suppose if we have a group like this one, if we could observe. So in this case, which one should be the number that I have to choose? So suppose, or if I choose in this manner also, suppose it would be very much easy for us to understand. So as per the first rule that we have observed, then the first rule says that we have to choose the longest chain, longest continuous chain, and we could bend that also. So for that, suppose if I have to choose the number, and I could choose the number in this manner also, that is 1, 2, 3, 4, 5, 6. So this is the 6th carbon atom that I have observed. So either this could be the straight chain. But I have observed that we could see a branch when I am numbering from left to right. So suppose if this is carbon number 1, this is 2, 3, 4, 5 and 6. So I could observe that this third number of carbon atom is having a branch. So basically, if I number it from left to right, so on third I am getting a branch. Okay, and what happens if I choose another method to decide that that would be the longest chain? So for that, another example that I could do is I could choose this also, like 1, 2, 3, 4, 5, 6. Even this is what I could choose. So therefore for that, so this is also, we have chosen a continuous chain which contains 1, 2, 3, 4, 5, 6 carbon atoms. And moreover, we could see that here also there is a branch. So what we have to choose, and the branch is over here also. So we should choose what? So according to the second law that we have, if two chains of equal length are present, so in this case the equal length is found to be 6. So if two chains of equal length are present, then choose the one with maximum number of substituent as the parent chain. So the earlier one, or this red line in which the 6 carbon are been enclosed, we could see that the only one substituent was been present, or the one group that was been attached in terms of a branch. While talking about this black one, or the carbons that are under the black portion, in this case basically there are again the 6 carbon atoms, and we could observe that there are substituents. Yes, the substituents are basically 1, and here it is 2. So basically there are 2 substituents. So that's the reason we have to choose the black as the longest chain, just for an insert to understand. So now this is where I could get 2 branches. That is one in when I count it from suppose left to right. So suppose I am giving it as number 1, 2, 3, 4, 5, 6. So I could get the branch at number 4, as well as I could get the branch at number 5, or the substituent at number 4 and number 5. That's the reason we have to choose this as the longest chain. So this is the rule that we have to follow. I'm just preparing you so as to we are going to solve the IUPAC nomenclature of the alkanes. So therefore these rules are being followed by us, and should be followed by us so as to understand this thing. So the second rule has been done. Now going towards the third rule that we have, and these are not specified as numbers, but these are the rules that we are following. So let us go with the next one that we have, that is the lowest number rule. So the lowest number rule, what does this rule says? It says that number the carbon atoms in parent chain. Parent chain is the one that we have chosen, the longest chain, that is called to be the parent chain. From that end, which is nearest to the point of branching, which is nearest to the point of branching, that should be from there we should number. And yes, the substituent carbon atoms must have the lowest possible number. So whenever we are numbering the groups that are being attached in a parent chain, or the substituents that are being attached to the parent chain, we have to give them a number in such a way that they should get the lowest number. That's the reason we have mentioned here to be the lowest number rule, and we are following the lowest number rule. So for that, the number which indicates the position of substituents are basically known as locants. Locants is the one, nothing but the location where we could see that at third position or at fourth position we could find a particular group. So that's the reason they specify the location of the group in the carbon number 1, 2, 3, or whatever the in the parent carbon chain is. So for, I will take the same example that I did earlier. So I'll take this example here itself, so you could easily imagine that. Suppose if I have choose the number that is from here, so it would be 1, 2, 3, 4, 5, 6. So I have got a number from one group or one substance was attached on the fourth carbon and fifth. What if I have choose the numbering, or I decided to number from here? That is, if this is 1, this is 2, this is 3, 4, 5, and 6. So the numbering is now started from this end, but I could see that this carbon has got the lowest number, or the lowest number where this group is been present. So therefore the number is 2. The locant is 2, and another locant is found to be at 3. So among this, that is 4, 5, and 2, 3, I would choose 2, 3 because it is following the lowest number rule. So that is the reason that even this is the rule that we have to follow, and we have successfully understood that what is the rule number 3, or we could understand what is the lower number rule that we have to give. So even this is what we have to consider to name a particular hydrocarbon in terms of the IUPAC nomenclature. So this was the third one that we have. So now let us talk about the next one, because there would be multiple things that we have to choose and we have to think about so as to give a IUPAC name. So it is very necessary for us to understand this rule. So now, talking about the next rule that we have. This is the next rule that we have, and it says that we have to assign a number to each substituent according to its point of branching on the parent chain. Yes, we have to assign a number to each substituent. So that is the reason what we have did is we have assigned a number. So for suppose if this carbon is attached to the carbon number 2, if I number from 1 to 3 in that manner, so I have to assign the number to that also. As I could see here, only one carbon is attached, or we could see that only methyl group is attached. So I could name it as 2 methyl or 3 ethyl. So that is the number that I have to provide to the substituent also. So that is what it explains, that we have to assign a number to each substituent according to its point of branching on the parent chain. So this is what we have understood. Now let us do for the next one. What it has written that if there are two substituents on the same carbon atom, assign them the same number. So let me explain with an example. Suppose if I have a hydrocarbon, and in this case, this is the hydrocarbon that I have drawn. So the first rule, let us follow the first rule and let us see that we are doing in a right way or not. So if I have followed the first rule, then I could see that I should choose the longest chain of the carbon atom. So for the instance, I could choose this also, which consists of basically 5 hydrocarbons in a straight chain, or either I could choose 1, 2, 3, 4, 5. Even this would be the same thing. So just for instance, suppose if I have taken this as a hydrocarbon as a longest chain, so therefore this would be known as the parent hydrocarbon, basically known as pentane, because we are talking about alkane. So this would be the pentane, and in this case I could see the branching, but I should number where. So in that case I should follow the another rule that we have did earlier. That is, we should give the number that is the lowest number rule, and we should give the number from which we could see that the substituents should get the lowest number if we start. So suppose if I am starting the number from here 1, 2, 3, 4, 5. So in this position, what I could see that at fourth carbon atom the substituents are being present. Even that is has no problem. But to do more precisely, if I do the numbering from left side, so therefore this would be 1, this would be 2, 3, 4, 5. So I could see that this substituents that we have are present or are being stated to have a lowest number according to the IUPAC. So now this is the correct method to number from left to right. And I could see that there are 2 carbon atoms that are acting as a substituent in the second carbon atom of the parent chain. So I should number them the same. So therefore this will also have a number of 2 which has been attached. The substituent will also get a number of 2 which is attached to the second carbon atom of the parent chain, as well as this will also have the same number as 2 which is attached to the parent carbon chain. So this is what we have explained the rule number 4 as well as rule number 5. So now let us go on further and let us study that also. So for that we have rule number 6. And what does the rule number 6 says? That if 2 or more different substituents, so the earlier example that I have represented, so that was the one which has the same number of carbon atom, that is the methyl group, and the methyl group that was attached to the second carbon atom. So what happens if the 2 or more different substituents are present, their names are entered in alphabetical order. So this is the next thing that they have asked to follow the 6th rule, what we have mentioned in this case. So suppose if I am taking the same example, and if I am just doing a normal change, like suppose if I am adding another carbon here, and moreover if I would see I could add another carbon here also. So again, if in this case, suppose in this case, this is not the change that we have to do, we could also choose this one. सर मैं ये एग्जांपल दूसरा लेना चाहता हूँ. So the numbers are being arranged in alphabetical order. So सर मैं ये दोबारा 6th नंबर दोबारा पढ़ना चाह रहा हूँ, मैं एग्जांपल थोड़ा गलत दे दिया. And let us follow the 6th one. And what does it says? That if 2 or more different substituents are present, their names are entered in alphabetical order. So the last example that we have studied that the 2 methyl groups are being attached to the same carbon atoms. So now let me give you another example so as to understand that how the 2 different groups will be there and how can we give the number or the naming with an alphabetical order. Suppose if we have a alkyl group, or suppose if we have an alkane in this manner, as you could see. Suppose this contains 2 carbons, or basically known as methyl, and this contains another one that is basically known as CH3. Suppose if we have considered that also. So this is what we have, and for choosing that what would be the IUPAC name, or for giving the IUPAC name, we should give the numbers in or naming in alphabetical order. Suppose again if I am following the first rule, so therefore it would be the longest chain. This would be suppose the longest chain that we have, and the numbering will start from that corner from which I could see that the substituents will get the lower number. So therefore this would be 1st, 2nd, 3rd, 4th, 5th, 6th, 7th. So 7 is the parent hydrocarbon that we have, basically known as heptane. So now this is the group that we have on the 3rd position, and this is the group that we have on the 4th position. So now the naming will be in an order of the alphabetical order. So as you could see that this is the ethyl group that has been attached, and ethyl group starts with alphabet E. While this is 4th, it stands methyl has been attached, so therefore methyl is with M. It starts with the alphabet M. So therefore we should name in alphabetical order. So now while naming this thing, ethyl group would be come first, and after that methyl group will be there. And let us follow the second next rule that we have. And what does it says? That if two or more identical substituents are present, then the prefix like di, tri, tetra, etc. are being used. And moreover, this is the thing that we have to note, is that the prefixes are not considered while writing the names of substituents in alphabetical order. Let me give an example so as we could understand this thing. Suppose if we have a hydrocarbon, let me name it as this one. Suppose this is the hydrocarbon that we have, and for naming, what we could write is according to the IUPAC. So we have to choose the first of all thing that we have to choose the longest chain. So suppose this is the longest chain that we have. And the next rule was to give the number, and that number that is to follow the lowest number, and to give to the substituents. So therefore we could number this carbon to be as 1, 2, 3, 4, 5 and 6. So therefore, because if we have numbered from right to left, then this would have been considered as 1, 2, 3, 4, and this substituent would have got the fourth number. But now we have followed the lowest number to the, we have given the lowest number to the substituent. So therefore this is the third position of the substituent that we have. So in this case, what we observe is, we observe there are two methyl groups. That is, in third position also there is a methyl group, as well as again on the third position also there is a methyl group. So we could write in this manner also that 3 methyl and 3 methyl, but the both are being same, so therefore we will merge it and we will give them a particular prefix. So therefore we could write it as 3,3, that is dimethyl. So this is what they have explained, that we should give the number, or we should give di, tri if multiple are present, if multiple same group are present, if 2 for di, 3 for tri, and so on. Now suppose if another group is been attached that is different from this group, that is the methyl group. Suppose in this case, in the fourth position, if C2H5, that is known as if ethyl group is being present, so the number will be to the ethyl group. Suppose in this case would be 4 ethyl. Actually this should be represented in a proper order, but for just an instance, suppose if in this case ethyl is the one that it has, and it has only one ethyl group, as you could see here. So what would be the preference name? Because E should come first, and then if we will see in an alphabetical order, then D should come first and after that E. But this di, tri, or this prefixes that we have uses, that doesn't matter when it comes to the order, or when it comes to the nomenclature. So the main thing which is important is the alkyl group's name that starts with an alphabet. So this alkyl group starts with an alphabet E, while this alphabet of the alkyl, it starts with M. So for that, what we are going to do, we are going to number or we are going to name in such a manner that this alphabet should come first, that is E, then M should come after that. So this is the thing that we have to follow the rule of IUPAC. So therefore 4 ethyl will be the first one, and after that 3,3 dimethyl, in which this di has no meaning, meaning in the sense when it comes to the IUPAC nomenclature in the preference of the alphabets. So this di doesn't have that preference, but this M has a preference after the alphabet E. So this is what the rule have said, that what we have learned in 7th rule. So now let us go on with the next one that we have, that is, let us do the next rule. And here it is: if two different substituents are located at equivalent positions from two ends, that is from left to right, or we could say right to left, when the chain is being arranged in a straight chain, so in that manner. So, or we could say in this case also that if two different substituents are located at equivalent positions from two ends of a parent chain, so the numbering of the carbon atom of the chain is done such that the substituents which comes first in alphabet order should get the lowest number. So this is what I want to explain you, that suppose if two different groups they are present in a parent chain, suppose like this one. This is one that I have explained, but let me give you another example. Suppose if this is a hydrocarbon, and in this case if we move from left to right, that is on the third position if I found or a methyl group, and in this position, that is from third itself, if I have found another, but in this case it would be an ethyl group, suppose. So the substituents are equidistant. How? Because as we move from left to right, I could see that the substituent is attached to the third number, or while if I number it from right to left, in this case it has been found to be again in the third number I have found a substituent. If I have seen that at what number or where is the substituent or the locant is, so I could see that at third position, that is if I choose from left to right or right to left, it would be the same, that is from on third position. On fifth position I could see, or if I move from left to right or right to left also, I could see on third position as well as on the fifth position. So therefore this is basically known as they are equidistant. The substituents are basically equidistant from both the ends, but the difference is the group. So in this case, as we could see that this is methyl group that is being attached, and methyl is the one that has an alphabetical order which starts with N, while in this case it is ethyl group and it is starts with E. So we have to number from where? From this, that is from left to right or right to left. So that is what we will observe here, this rule. So because in this case, what the thing that I have mentioned is, if two different substituents are located in equivalent position from the two ends, then the number of the carbon atoms of the chain is done such that the substituents which comes first in alphabetical order should get lowest number. So in this case, this is the ethyl one that is comes first in the alphabetical order. So therefore the numbering will start from that position, from that corner where it is being the lowest. So therefore it will get the lowest number. So therefore this will be the first, second, third, fourth, fifth. So that is the reason that we will start the number from, that is from that corner where we could see that the alphabetical alkyl group which comes first will get the lowest priority in terms of the number. So this is what the 8th rule that we have studied about. So now let us go on further and let us see the next rule that we have. So the next rule is this one, which says that the numbers are separated using comma. Suppose if we have two numbers, suppose 2 or 3 more than numbers, just like we have did an example where we could see that on the third position we could see that there are 2 methyl groups. So therefore how can we name that? We can name that, suppose if I've taken an example in this way. Suppose in this manner, if I have taken an example like here. Suppose if this is the one. So I could see that there are 3 substituents. One is at position number 3, again at 3 and 5. So how can I name this? So for that I should number as the number is proper, and we have followed the 8th rule, or the 8th rule that we have mentioned. And in this case basically how I could write, because these two are the same, and we could write in this manner, that is 3, 3, and we don't have to write 3 ethyl, 3 ethyl. So we will merge it and we'll make it 3, 3, because these are the two numbers, so therefore we are differentiating it with comma. So 3, 3, and there are 2 methyl, so therefore this would be, sorry, 2 ethyl, so therefore this would be diethyl. And let's study the next one. A number and a word are separated using hyphen, that is this symbol dash. We usually express in that way. So therefore it will be expressed in hyphen. So therefore as I could see that this is a number and this is an alphabet that it starts, so therefore for differentiating that we will use hyphen. So therefore this is the correct method to write the IUPAC nomenclature of a particular hydrocarbon or alkane or in any group. So therefore this is 3, 3 hyphen diethyl, and let us do the next one. The IUPAC name of an alkane is written as one word only. The IUPAC name of an alkane is written in one word. So for that, let me explain this as the same example. So as I could see that there is suppose if this is an example that we have to mention, and in this case there is on third position there is ethyl, and again on the third position there is ethyl, and I could see that these two are being expressed here, that is 3,3 diethyl. But on fifth position also there is a methyl group. So how can we write that? So because this is an alphabet, so to differentiate with a number, so 3,3 hyphen diethyl 5, again a number starts and I have to express an alphabet and word or alkyl. So therefore in this case, therefore there I would write 5 methyl, and what is the longest chain that we have? This contains 7 carbon atoms, and 7 carbon atoms are nothing but when it comes to alkane it is known as heptane. So this would be heptane, and these two words will not have any kind of difference, so it would be a same word. That is the 11th rule that we have followed, so therefore this would be the same thing. So the actual name of this would be 3,3 hyphen diethyl hyphen 5 hyphen methyl heptane. So this is the name that we give. So that's it. But it is not necessary that the substituent groups would be a simple one like this. It would also have a branch. Yeah, we are now moving towards the next kind of the nomenclature, so let us study about that also. So this is what we are going to explain, that is the rule number 12. So what does this explain is, so now we are following the next rule, which says that if the substituents, that is the side chain, is further branched, that is it is named as the substituent alkyl group. Means what is the side chain that they are talking about is, suppose if the side chain or the substituent is also having a branch in it, and that branch is been attached or that particular group is been attached to the main parent hydrocarbon, that is the continuous longest chain carbon atom that we have decided. So in that case also, how we can name that? So that is what they are explaining, that it is named as the substituent alkyl group by numbering the carbon atom of this group attached to the parent carbon as 1. So suppose if this side chain will have a particular carbon group that would be attached to the main carbon atom, that is the main parent carbon atom that we have chosen as the longest chain of continuous chain of carbon atom. So now what will happen is, we will number that side chain's carbon atom which has been attached to the parent carbon atom as 1, and then we'll decide that the whatever else that it will have, another branch also it will have, so we will name in that manner. And we'll give an example of this by taking I'll explain you this with an example. And yes, moreover we could see that the name of such substituent is enclosed in brackets. So this side chain that will have a particular name according to the IUPAC, even that should be described in the overall nomenclature of the hydrocarbon, that is for alkane. So in that case they should be enclosed in the brackets so as not to get confused with the main parent carbon atom or the main parent carbon atom that we have decided or we have chosen. So for that, let me give an example. Suppose if we have an alkyl group or a alkane group like this one. Suppose this is an alkane that we have chosen, and so for this thing what we have to do is, we have to choose such a long chain, a continuous chain that would have the more number of carbon as well as branching also. So let us decide in this manner. Suppose if I have chosen this to be the longest chain, that is this to be the longest chain, so I could choose this to be the longest chain, where I could observe that suppose if I am drawing in this manner. So if I have chosen this to be the longest chain, then I could see that the total number of carbon is 1, 2, 3, 4, 5, 6, 7. So there are 7 carbon atoms that are been in this longest chain if I have chosen the rule number 1. And more, we could see that the number of substituent groups is also more in this case. But let us first check whether the first rule has been obeyed or not, because the first rule says that we have to choose a continuous longest chain of carbon atom. So suppose if I choose this one, that is 1, 2, 3, 4, 5, 6, 7, 8. So in this case it was 7, as I could see. So 7 carbon atoms was been attached in this that longest chain. But if I choose this one, so this is the chain where I could observe there are 8 carbon atoms. So 1, 2, 3, 4, 5, 6, 7, 8, 8 carbon atoms. So therefore this is now my main parent hydrocarbon, and that is because of it is been present 8 hydrocarbons are been present in a straight chain or in a continuous longest chain. So therefore the name of this would be basically octane itself. And moreover, we could see that there is a side chain, and the side chain is also will have a branch. So first of all, let us follow the IUPAC rule that we have got to know. So we'll name the substituent with a lowest number that we'll get to it. So suppose if I have numbers from here, that is 1, 2, 3, 4, 5. So therefore this will get the 5th position, or the locate would be on the 5th carbon atom according to the IUPAC. But is there any other method so as to give a lowest number? Let us check that also. Suppose if I have numbered it from this end, so 1, 2, 3, 4. Yes, this has got a lowest number, that is to be 4. So now this is the one which has been attached to the 4th carbon atom. And moreover, we could see that this substituent that has been attached to the 4th carbon atom is further having a side chain, or further having a branch, because this if I consider this to be the straight chain, again I could see that this is the branched one. So for that I should name, or I should specify this also. And for that, let me explain by taking the 12th rule that we have studied. It says that if the substituent, that is the side chain, is further branched, so in this case this side chain which is attached to this straight chain or this parent carbon atom is further branched. As you could see, again it has been branched, it is not a straight chain, it has been branched. So it is named as the substituent alkyl group. So therefore this will be the substituent alkyl group. But by numbering the carbon atom of this group attached to the parent chain as 1. So because this will have a carbon atom that will be attached to the parent carbon atom. So therefore this is the parent carbon atom that we have, and this carbon is attached to the parent carbon atom. Therefore this carbon, the atom that we have in this case, will get a number 1. So therefore this will get the number 1. And for that, what we could write it as, suppose in this case this will get the number 1. And for naming that, it would be very much easy. So first of all, we'll give the name to this one. So the name of this substituent is basically, as we could see that 1 methyl is attached here and 1 methyl is attached over here. So I would name it as 1, 1, that is dimethyl. And this is the overall that has basically 3 carbon atoms. So therefore this would be propyl, and that has been attached to this one in this section, as you could see. Fine. So now, but this overall group is attached to the 4th carbon atom. So therefore what would be the name of this? The name of this would be very much easy to describe, and according to the 12th rule that we have discussed. So therefore the name of this would be basically 4, and I am differentiating with the alphabet. So here it is the one that should be in the bracket, so as not to get confused between this one. So therefore the name of this would be basically, I could write it as 4, 1, 1 dimethyl propyl, and bracket would be closed, and yes, this would be known as octane. So this is the name that we give. So that was the another rule that we have mentioned in this case. So therefore this is the one that we have explained. So these were the rules of the IUPAC name to name an alkane. So thank you friends for watching this video. I hope you have understood this video very clearly, and yes, there were many rules that we have followed by giving by following which we have named various IUPAC structure that we have drawn. So this is the rule that we have to follow, and share this video with the friends, and yes, don't forget to subscribe Ekeeda channel. Thank you so much.